Welcome back to part 3 of the ideal gas investigation. This is Mr. Keppel. In this video, I'll be showing you how to analyze the data and actually come to some conclusions about what the gas constant and the absolute zero temperature are. I'm going to close this out. So I actually was just in here looking up the accepted value of absolute zero. So we're going to remember this and we'll come back to it in a little bit. But you'll actually notice here that I have finished collecting all the data using the crappy 500 particles and default container width. Do not use these. This is going to give you a lot of uncertainty in the end, and you're going to want to try to come up with that methodology that reduces the uncertainty. All right, what you'll also notice I have Logger Pro open in the background, so you'll want to make sure you open up Logger Pro. And then what I want to do is I want to get my data from Excel over into Logger Pro. But first, I want to actually take my raw data and process it. Now, there's not a lot of data processing to do here, so realize that what we need to do is look at our model, which was in here. And so the model was just PV equals nRT. We didn't have to like change anything. Like we just had straight up pressure and temperature. So we don't actually need to like square it or cube root it or like inverse it or anything. We're just going to straight up use our pressure and temperature as they are. So we're good. And remember that we're going to find from our graph, the gradient and the y-intercept are going to let us determine the r and the t. And that's what we're going to be using Logger Pro to do. So the process data is just going to be this and that. That's it. It's just going to be these two values here. So let me paste them down here. I don't want kilopascals. I just want to be pascals. So that way the units work out more nicely that way. Okay, the temperature, I'm just going to use this exact same data. I don't need to process it, but for the pressure, I do need to process it. I'll take the pressures and multiply by 1,000. So that way they are no longer in kilopascals, but they're just in pascals. Then I'll grab these guys and just drag it down. Good. So that's my process data. There's nothing else to it. I'm going to take this process data and import it into Logger Pro. Now, the easiest way that I know to do that is to just go in here and now look, there's only 2 columns. So if I drag this over, you'll notice that there's only 2 columns here. Is we're going to want to, first of all, go to data and then add 2 new manual columns. So that way we have 4 columns. And then I'm just going to take this. I'm going to eventually copy it. I might as well just do it. I'm going to copy this, click here, and then paste it over. And now I just need to make sure that I rename these columns so that way we know what the heck is going on. All right, so first up, actually, this is going to cause some problems. See, so I want to go, I'll figure this out in a little bit. Okay, here we go. So I know that this is the temperature. So I'm going to go to column definition, and I'm going to write out temperature. And the short name is capital T. The units are, look at this, the degrees is right here, degrees Celsius. This guy is going to be my temperature uncertainty. The short name is upper Greek delta T. The units are the same, Celsius. The next column, I'm just double clicking on this column if you guys couldn't figure that out. I'm just double clicking there. This is my pressure. The short name is lowercase p. The units are pascals. And then this one is my pressure uncertainty. And the short name for this is going to be uppercase Greek delta P, and the units are pascals. Okay, the first thing we want to do is make sure that our graph is the correct quantities being graphed. So I know that I wanted temperature down there, but it's probably graphing the wrong thing. Come on, let me bring it over. Okay, here we go. Yeah, I don't want to graph the temperature uncertainty against temperature. I want to graph the pressure against temperature. And then you can see that it actually goes ahead and graphs the pressure here. I'm going to get rid of my video. I think I'm just going to keep it off for the rest of the video. So now I'm graphing my pressure against temperature just like that. Perfect. Okay, the next thing we want to do is we want to actually see these dots. They're way too big. So I'm going to go in here to scroll. Let me move these guys down. Let's make it smaller. Okay, so what I want to do is double click the pressure and go into options and then make it be a filled circle, but make it be tiny. And actually, I'm going to also turn it to black because I like my data points to be black. So now I have these tiny circles in there, which is way better than those big fat blue circles. Okay, next we want to add the error bars on here. So the way you do that is you just double click on a column and then you go to error bar calculations and you say use the column. So now this is the temperature. So we want the error bars to be the temperature uncertainty. So I'm saying, hey, for this column, for temperature, the error bars are going to be from this second column. And I'll do the same thing. You can see the error bars have just shown up. And I'll do the same thing for pressure. Error bar calculations, use column pressure uncertainty. And so now I'll have these nice vertical, it didn't show up, I'm gonna have these vertical and horizontal um, error bars. There we go, perfect. These beautiful error bars showing up right here. Great. Next, we're gonna do a curve fit. So I'm gonna click this curve fit button, and we know that it's supposed to be linear. So I click linear, and I'll try the linear fit. Click try fit. Why aren't you trying? Try the fit. What the heck? It, I I don't understand. Is it error encountered during curve fit? Select additional points to perform curve fit. Okay, apparently I had some area selected. Okay, here. Okay, so watch out. If you have stuff selected like this, it's not going to let you do it. You need to make sure that you click to clear out your selection. Okay, curve fit, linear, try the fit. Okay, there we go. The fit is there. Beautiful. Hit OK, and now it's showing up. There's my fit. I'm going to go in here and say, don't show the uncertainty. We don't need that. And I'm going to use the entire range. And then when you use the entire range, if you guys didn't see what that does, there's this little bracket that shows up here, which is kind of gross, and I just don't like that. So I click show entire range and it makes those brackets go away. I also want the appearance of this to be larger, so I want it to be 12-point font, so it just looks nicer. Okay, there we go. And then we probably don't need all those decimal points, so you can actually say, you know what, just do 2 precision, that's fine. Or maybe we want to keep it out to 4. I'll probably just keep it at 4, whatever, it's fine. Okay, so next, we're going to add the minimum and maximum gradient lines. So the way I do that is I click on curve fit again, and I click manual this time. So instead of doing automatic curve fit, we're going to do it manually. We're going to put in the stuff on our own. So we're going to use the same slope and intercept values from the automatic fit, and you'll see why in a second. So 1.962 E4, that's my slope. I got it just from right there, slope. And then the intercept is 5.423 E6. And if I hit OK, a new line will appear, and it appears exactly on top of the old line, which is fine. I'm going to go into this. This is called a manual fit. I'm going to choose this to be my maximum gradient. I'm going to do a font size 12, and I'm going to make this guy red. Nope, not dark pink, red. I'm going to click on use entire range, and I'm going to click on enable line drag. Now what happens is when you enable the line drag, it actually gives you these little diamonds that allow you to adjust where this line is. And that's great because we're going to want to put this line so that it goes through the error bars. So I'm going to pull this down until it goes through the lower right hand side. Remember, I'm taking my vertical bars and matching them up with the horizontal bars to that corner because that's the lowest possible where that data point could have been. And then I'm going to do the same thing up here is raise this up to the highest possible, to the upper left-hand corner. And when you adjust these, you always want to make sure that after changing one side that you check to make sure the other side didn't change, and it did slightly change. So I'm going to fix that. About trying to get it about, oh, that's good. That's close enough. Okay, there we go. That's perfect. Once you've got it set, double click this box again and turn off the line drag so that those diamonds go away. And now you can't make any more changes to it. We just need to do this again for the minimum gradient line. So I'm going to do the exact same thing, 1.962 E4, and the y-intercept 5.423 E6. Hit OK. It's going to be there. It's just on top. I can't see it right now. So I double click on this box. Appearance, 12-point font. We're going to do Hunter Green. Use entire range. Enable line drag. Now I can see the green. We're going to raise this guy up to the upper left hand of the bottom point, and then raise this guy down to the lower right side of the upper point. And remember, once I change this, I got to go back here and make sure that that one didn't change. It didn't change too much. I'm just going to do it again just because for good measure. Okay, now it's looking good. I'm double clicking on this, turning off line drag. Okay, perfect. Okay, so now I'm going to move this over to here. All right, now I'm done. So now I'm going to go over here. I'm going to click on save. I'm going to save this as the ideal gas experiment. And now I'm ready to go. This is all finished. I'm making sure it looks good. Great. And I'm going to click this auto scale one more time. Okay, now the last thing is this actually isn't where the action is, because remember the action, like we talked about in the previous video, the action for this graph was down here in the x-intercept. So now I'm going to change the display here by making this lowest value go to 0, and then making this value go to -300. And now I can see where that x-intercept is. And so notice that our best estimate is going to be here at -276. Our what is this? Minimum gradient line is negative 289, and our maximum gradient line is negative 262. So that gives us a range of values within we think absolute zero is within. Okay, now this is the graph that I want to use. I'm gonna make sure that all 5 data points showing up. 1, 2, 3, 4, 5. This is the graph we want to use. Now I'm gonna save. Okay, so next what we're gonna do is I'm gonna make a little report here. I'm going to paste in the data tables, paste in the graph, and then we're going to figure out what the actual values of the gas constant and absolute zero temperature are. So let's grab the data tables first. So you can imagine this is like your Word report. So I'm going to grab my raw data table, copy it and paste it. And then I'm going to grab my, this one, my process data table, copy it and paste it. Oops. So this is what you'd be doing into your actual report file, your lab report file. Next, I want the graph. Now, a lot of people think that you should just take a screenshot of this. Don't do that. What you do is you 2-finger click on this and hit copy. Now I've just copied this graph, and then that way, like weird like screen display artifacts don't show up. Now if I go back in here and paste, now a clean, wow, it's huge. A clean version of the graph is going to show up where there aren't any like user interface artifacts and everything looks really nice. And it's just way cleaner to do it that way. There's my graph. Okay, now I'm ready to actually, from this graph, determine these gas constant absolute zero stuff. So I'm going to zoom in on this part here because I'm going to need this for the next step, which is going to be done in Excel. So what I'm going to do is remember that the equations we needed were to find r, we need the gradient, v and n, and to find t, we need the y-intercept and the gradient. So we're gonna calculate a best from this data here. We're gonna calculate a best gradient, a best y-intercept, a max, and a min. We're gonna do all that using this data here, and then we're gonna calculate a best max min r and a best max min t, and then we're gonna use that to actually find out what our measurement is. Okay, let's do it. So the best gradient is 1.962 E4. The maximum gradient was 2.038 E4. The minimum gradient was 1.885 E4. The best y-intercept, this is the black one's the best. The best y-intercept was 5.423 E6. The max intercept was 5.380. I didn't mean to click on that. 5.380 E6. The minimum was 5.465 E6. Okay, next I want to come up to here. Remember these N and V values. We're going to want to use these guys to do the calculations. Let's do it. So to find R, we're going to take the gradient. I'm going to open up parentheses. I'm going to take the gradient and I'm going to multiply by the volume, which was up here. So click on that cell. I'm going to close the parentheses. You notice I'm right here. I'm going to divide by the number of particles, which is right there. And so that gives me my best gradient. Now what I'm actually going to do here is, because that volume, I'm going to press F4 here to fix these, put dollar signs in front of them. So they're fixed references because I don't want these guys to drag when I autofill down here. So now I'm going to autofill this across. I do want it to move the gradient as I go, but I didn't want it to move the values up there. Okay, next I want to find the temperature. The absolute zero temperature is going to be the y-intercept. That actually it's supposed to be a negative there. I forgot to put that here. It's the negative of the y-intercept. I'm going to verify that real quick. Yeah, we calculate here that negative because we had to divide, we had to subtract that to the other side. It was a negative y-intercept over gradient. So I'm going to come back to my Excel spreadsheet. I'm going to take the negative. Let me just start over. I'm going to take the negative of the y-intercept divided by the gradient. So that's my absolute zero, best estimate, negative 276, not far off from the accepted value of negative 273.15. We're going to drag that over to get the maximum and the minimum. I'm just double clicking here to make sure that it's pulling from the correct cells. Okay, great. So now our best R is this, and our best T is that. But now what do we use for the uncertainty? Well, there's two possibilities. We can either use the difference between the max and the best or the difference between the min and the best. So we're going to try both. So first up, I'm going to take the maximum minus the best, and then I'm going to take the minimum minus the best. And whichever one gives you a larger value, that's the one you use. And notice here that they're both giving us the same, so that's great. that means we're going to use 0.32. And then here I'm going to do the same thing. I'm going to take the max minus the best, and I'm going to take the min minus the best. And then here we can see that it was actually the 13.5 that was the bigger one. So we're going to want to use the 13.5 instead of 12.4. You always want to go with the bigger error because you're more confident that way in what the answer is. Okay, let's look up what the accepted value opposite zero is. So it's negative 273.15, and so we're at negative 276. So it looks like we're within the range there. If we go up and plus and minus 13.5, that does fall within the range. In the IB data booklet, we can look up the accepted value of the gas constant. It's 8.31. So if we look at this, 8.27, if we plus or minus that 0.32, that is also within the range. So it looks like our experiment does in fact agree. Okay, I'm going to finally go back here and record these numbers down. So the way to do that is to pull up the Excel spreadsheet. I'm going to copy this, paste it in here. Okay, so here we go. So now this part is important because you have to remember that let me increase the font size on this. You have to remember that the precision that you express your uncertainty has to match the precision of your best estimate. Okay, so for our experimental value for the gas constant, come on, I don't know why this is shaded. Whatever, it's fine. Okay, so I'm going to go right here. So for the gas constant, I'm going to put 8.27, 8.27 plus or minus 0.32. But here's the problem. The methods that we use to determine the uncertainties were not very precise. So we can't justify that second digit there. So it's just going to be 0.3. Now, the precision in our uncertainty has to match the precision in our best estimate. So we're going to have to round off. Man, come on, why isn't it letting me change my pen color? Everything just goes wrong. It's so frustrating. Like trying to make these videos. Okay. So here, that means we're going to have to write that as 8.3. So that's our value of the gas constant, 8.3 plus or minus 0.3. Remember, the accepted value was just 8.3, 8.31. So we are within range there, which is great. For absolute zero, our best was negative 276.4, negative 276.4 plus or minus 13.5. Once again, the techniques that we used to estimate this weren't very good, so we can't justify that 5, and we probably can't justify that 3 either. So we're just going to leave it as a 10. And now, since this is the tens place, I got to round to here. So that's going to be negative 280. So the best that we can say absolute zero is negative 280 plus or minus 10. The accepted value is negative 273.15 degrees Celsius. And so this is how you would end up presenting your findings in the report. If you were writing an actual lab report, you would then go ahead and compare these. And we notice that we have agreement. However, the uncertainty is pretty large here. We probably should have done a better job of controlling the error. And we can do that by coming up with a better methodology for the pressure. Okay, that's it. I'm going to end the video here, guys. Make sure that I want you to write up a little thing just like this, like just in a Google Doc or whatever. I want to see your data tables. I want to see your graph, and I want to see this little table of what your experimental value is compared to your accepted value. Okay, I'll see you guys later. That's the end of this video. Sorry for all the wait and everything, but alas, I've done it. Have a wonderful day.